All right, I'm starting to wrap everything up, getting close to the end here. We're now in section 7.5. There will probably only be one part to this video. This is not a very big section either. Section 7.5, and we want to talk about rationalizing the denominator. Now, I know at this point that has absolutely no meaning to you. I'll talk about that in just a second. But before I get to that, let me show you something here. Let's suppose I have a fraction, 2/3. Now, let's suppose that I wanted to, just watch now, you don't have to write this down. Suppose I multiplied the top number by 5 and the bottom number by 5. When I do, let's see what we get. We get 10 over 15. But if you reduce 10 over 15, what do you get? 2/3. So in other words then, do you agree that 10 over 15 and 2 over 3 are the same? The mathematical word is we call them equivalent fractions. Simply put, they're the same. This is what I'm wanting you to see in this, and we're going to be using this in just a second. If you start with a fraction and you multiply the numerator of that fraction and the denominator of that fraction by the same number, you get an equivalent fraction. Now, why does it work that way? Because look at what we're multiplying by. We're multiplying by 5 over 5. Well, what is 5 over 5? 5 over 5 is just 1. Matter of fact, this is a word I use. I call 5 over 5, I call that a super 1. So anytime you multiply by a super 1, what's a super 1? 3 over 3, 10 over 10, 50 over 50. All of those are super 1s. So when you multiply by a super 1, you get an equivalent fraction. Now, what does that have to do with this rationalizing? Now, this is one of those things I'm not going to go into a lot of detail on because the math behind it you don't care to hear anyway, but I will give you the gist of it. In mathematics, we leave radicals in our answer all the time. If you go back in the last section, did I have radicals left in a lot of the problems in the last 2 videos? Heavens, yes. A lot of our answers had radicals in them. But one of the things in mathematics that we never do, for reasons I won't go into right now, is we never leave radicals in the denominator of a fraction. So what I've got to do is I can't leave my answer as 5 over square root of 3. Because based on what I just told you, we can't leave this radical in the denominator. Now you say, well, just get the square root of 3. I can't get the square root of 3. Well, reduce it. It won't reduce. So will this reduce in any way? No. But can I leave this as a final answer? No. Why not? Because we just said we will never leave square roots in the denominator of a fraction in our final answer, ever. The process by which we get that radical out of the bottom is called rationalizing. So when I say rationalize the denominator, that just simply means get this radical out of the denominator. Now, first of all, you can't just throw it away. You can't just say, okay, I don't like that square root there, so I'm going to just change it to 5/3. Because if you take your calculator, this is not equal to that right there. So what I have to do is, I have to do something mathematical to get rid of this. Well, what did we just learn about any fraction? If you multiply it by a super 1, you get an equivalent fraction. So what I want to do is I want to multiply this by something over itself. But here's what else we have to put together. If you'll remember the very last thing I did in the last video, which is why I did that. The very last thing in the last video, we learned this. Anytime you take a square root, let me just pick a number, times itself. Anytime you take a square root times itself, it just simply gets rid of that square root. And I showed you why in the last video. So here's what I'm going to do. I've got to get rid of this square root of 3. So I have to rationalize the denominator. So to get rid of a square root of 3, what I'm going to have to do is, if I multiply it by itself, that gets rid of the radical. But this has to be a super 1. So the top has to be a square root of 3 also. So 5 times square root of 3, no, you cannot multiply those together. So 5 times square root of 3 is just 5 square root of 3. And then square root of 3 times square root of 3 is square root of 9, but that reduces to just 3. And so this is mathematically the same as that, this and that. If you took your calculator and punched in 5 times square root of 3 divided by 3, that's the same thing as 5 over square root of 3. The difference is this one doesn't have the square root in the denominator. This one does. So what you're looking at right here, when I do this, this is called rationalizing the denominator. So simply put, here it is. To rationalize the denominator, you just simply multiply numerator and denominator by whatever square root is in that denominator. Multiply numerator and denominator by whatever square root is in that denominator. Now, I would still reduce my answer if it would reduce. So I'll still talk about that when we get to those examples. Okay, so let's do some examples now. And the instructions here, rationalize the denominators. All right, so here we go. 7 divided by square root of 3. Now, once again, you say, well, Mr. Rayner, don't we need to see if square root of 3 would reduce first? Sure, there's nothing wrong with that. But it doesn't. And not only that, I can't leave the square root in the denominator. So how do we rationalize? We multiply by a super 1. So what am I going to multiply by? Well, to get rid of a square root of 3, I have to multiply it by itself. But this has to be a super 1. So I have to multiply the top by that also. So 7 times square root of 3, you multiply that 7 times that 1 that's in front of that square root of 3 to get that. And then square root of 3 times square root of 3 is square root of 9, but the square root of 9 is just 3. Now, next common thing I'll have students ask is, they'll say, Mr. Rayner, will those 3's cancel? And I'll say, what 3's are you talking about? And they'll say, that 3 in the bottom or that 3 in the top. I don't see a 3 in the top. And you say, well, sure I do, right there. That's not a 3. That's a square root of 3. Square root of 3 is like 1.4, something like that. That and that are not the same two numbers. Now, if I could reduce this, I would. But you can't reduce that that's not under the radical with one that is under the radical. That's two entirely different things. Okay, let's do another one. 8 divided by square root of 6. This one's the exact same thing. So I'm going to multiply top and bottom by whatever's in the bottom. So this would be 8 square root of 6 over square root of 6 times square root of 6 is square root of 36, which is just 6. Now, in this case, can't touch that and it won't reduce, but I can reduce this because 2 goes into both of these. 2 goes into 8, 4. 2 goes into 6, 3, and you don't touch what's under that radical. I would reduce it if it would, but there is no perfect square that goes into 6. So this is same as this, but this doesn't have the radical in the bottom, which means it is rationalized. All right, let's do 4 more examples. 5 square root of 7 over square root of 5. All right, so I've got to rationalize. Going to multiply top and bottom by square root of 5. Now, 5 square root of 7 times 1 square root of 5. 5 times 1 is 5. Square root of 7 times square root of 5 is square root of 35. Over square root of 5 times square root of 5 is square root of 25, which is 5. The 5's cancel, leaves 1, square root of 35. You say, well, we need to reduce square root of 35. It is reduced. There is no perfect square that goes into 35. You say, well, 5 times 7. 5 and 7 are not perfect squares. So square root of 35 is a reduced radical. Okay, let's do another one just like that. This one works the same way, so I'll just go straight through it. Multiply bottom and top by square root of 2. Square root of 2 times square root of 2 is square root of 4, which is 2. And 26 square root of 3 times square root of 2 is 26 square root of 6. That won't reduce, but you can't touch it. But you can divide 2 into 26, which is 13 square root of 6. Okay, 2 more examples. Square root of 5 sevenths. And you say, well, you don't have a square root in the bottom here. Yes, you do. Because that square root's over both of these numbers. Now remember, if you're adding and subtracting under there, you can't break it apart. But if you'll remember, I said if you're multiplying or dividing under a radical, you can. So what I can do here is I'm going to break this into 2 parts because I don't like that fraction under there. Let's look at it separately. So that and that's the same thing. Now I've broken it apart, but I can't leave this radical in the bottom. So this is where the rationalizing takes place. Multiply top and bottom by square root of 7. Now, square root of 7 times another square root of 7 is just going to give you 7. Oh, square root of 49, but square root of 49 is 7. But then square root of 5 times square root of 7 is square root of 35. 2 comments again here. First comment, no, square root of 35 does not reduce. You cannot break, you don't believe that if you're using your calculator. Punch in square root of 35. If you're using your calculator to reduce, it won't reduce that. There is no perfect square that divides into 35. And you say, well, can we divide 7 into the 35? That's not a 35. That's a square root of 35. So no, you cannot divide that 7 into that square root of 35. So that is your answer, and it is rational. Last example here. Square root of 25 over 6. First thing I'm going to do is break this up into 2 parts. Now, since the top is perfect, what is the square root of 25? It's just 5. So I'm certainly going to go ahead and do that because that's easy to do. Now, you still can't get the square root of 6. No, it won't reduce. But I can't leave that square root in the bottom either. So this is where I'm going to multiply the bottom and the top by square root of 6. So when I do, square root of 6 times square root of 6 is just a 6. And then 5 times 1 square root of 6 is 5 square root of 6. And that is the answer to that problem. And it is now rationalized, and this does not reduce any further. So this completes section 7.5, rationalizing denominators. So the next section, we have 2 sections left, will be section 7.6, and it will have several videos to it.